Greetings, Algebra 2. Trig, students, you've completed Chapter 7, so let's move on to Chapter 8. This is what we call logarithmic functions. So hopefully you have a piece of paper, which I gave you in class, to just do the graph part of these notes. We're going to start from Chapter 7 and work ourselves into Chapter 8 right now, right here in Section 8.1, which is inverse of an exponential function. So we'll start with sort of an easy one. Y equals 2 to the x. And I want to go ahead and graph this. So I'm going to make an x and a y, make a table. Tables are a really nice way to sort of prepare yourself to graph, also to show somebody what you're trying to do on a graph. If you notice that the way the graph is set up, it starts at -2, so I think I'll just go ahead and put a -2. -1, 0, 1, 2, 3 for now. Okay, so now I'm going to just kind of think this through in my head, but I'm going to go to my calc in a sec. If I take a 2 and I raise it to the -2 power, so 2 to the -2 power is the same as 1 over 2 squared, which would also be the same as 1 over 4, also known as a fourth. If I take 2 to the -1 power, that's the same as 1 over 2 to the first power, also known as a half. Sort of write that over here. Anything to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. So I'm going to come over here and graph this. So -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8. And as best I can, I'm going to go ahead and just draw this graph in right here. And I'll label this y equals 2 to the x. Just as a reminder, if you get your calculator to help you do that, I'm going to type in 2 to the x here. And just for fun, just to kind of remind you of the power of your calc, if you feel like it, you could change it out of full screen and change it over to this graph table screen, which is not something I use a lot, but sometimes it's kind of cool because you can look at the table and the graph at the same time. So I'm going to go ahead and do that, and I'm just going to hit graph and see what I see. Now, as I look at this, I see that my table is starting at 20, and I say, well, I don't want it to start at 20. If I want to make it look like my paper, I want it to start at -2. So I want to remind you that if I hit second window, I go to this thing called table set. And table set allows me to, rather than having to scroll, I can actually type in -2, and then my calc will take me immediately there. So now I'm going to go ahead and hit second graph, which when I hit second graph, I actually can maneuver around in my table in this particular screen. And so you can, the cool thing I think about this is as you're scrolling through your table, you can see the points that we just plotted on our graph. So there you have it. That would be y equals 2 to the x. So this particular chapter is about finding the inverse of an exponential function. So I want to just go through the same process we've done in the past to do such a thing. So if we start with y equals 2 to the x, the process we've done in the past is we say, okay, to find the inverse, really what we're doing is we're switching our x's and our y's. So we would have x is equal to 2 to the y. And then our job has been in the past when we do an inverse to actually solve it, and we need to solve it for y. So this is where we are going to encounter our first problem, because using the tools we've learned so far, you can look at that for a while and say, how do I solve that for y? And we really don't have a way to do that right now. So what I want to do first is get this graph, and then I want to talk about what we're going to do to actually name it. So if we want to do the inverse then, if you remember, all the inverse is we are just switching our x's and y's. So even though right now we might not be able to name this, we will be in a minute, we can graph it, because all we're going to do is, if we have a -2x and a fourth y, we're just going to switch their position. So I have 1/4, -2, 1/2, -1, 1, 0, 2, 1, 4, 2, 8, 3. So I'm going to come over here on my same graph, and I'm going to graph. 1/4 -2, 1/2 -1, 1 0, 2 1, 4 2, and I'm going to come out here and graph 8 3. And as best I can, I'm going to go ahead and graph this in. Now, I've already drawn in the y equals x line, so hopefully you can see that clearly we do have a situation here where, just highlight this y equals x line right here, where if I was to fold the smartboard on that line, I would definitely have a reflection over y equals x. So let's talk about naming this now. If I was going to say in words like what y is, if I had to do that, I could say, well, y is the exponent, because I hope we can agree y in this case is an exponent. So y is the exponent for base 2. In this case, 2 is our base, to get x. Okay, so there's sort of a description in words what it is. So what I want to do right now is install for the first time the word logarithm. Because really what y is it is what we call a logarithm. And you're going to hear me say this over and over again. And basically the thing that I'm going to say over and over again, I'm going to write it right here, is that a logarithm is an exponent. And if you can install that tape, it will very often make it easier for you to deal with these things called logarithms. So what I'm going to do then to actually write this equation is I'm going to write y equals, because I do need to solve it for y, and now we are declaring that y is an exponent, but we can call it what we call a logarithm. Now, to base 2, because the 2 is here, showing a logarithm, we show the base below it. And I think once you get working with these, you'll be able to understand that, because like running around the bases in baseball or softball, the base is below. And then the only thing remaining is an x. So this right here, y equals log base 2x, describes this inverse. So I'm going to come back up here, and I'm going to write that. Y equals log base 2x. And I'll come over here and also label this. Now, your calculator will graph that, and we're going to work with this more in the next couple sections. And if we were to go to our calculator and hit y equals and type in log x, you are going to get what's called a common logarithm, which has a base of 10. So that's not going to give us what we have in this particular situation. So I'm going to show you sort of a little trick in order to actually graph a logarithm of base 2, and what we need to do is take that log x and divide it by a log of 2, and you'll understand why in the future, but for now it will at least allow us to get this onto our graph. So if I hit graph now, you can see this coming on the screen. Now I'm going to go ahead actually and change my mode back here so I can see my graph a little bit better. So I'm going to go down here and change the mode to full. And I think I'm also going to change my window a little bit so I can see a little bit more. So let me just let this graph. So I'm going to change my window, and I want to get out a little bit further on my x-axis so I can see a little bit more. So I guess I'll take that out to 10 so you can see something a little bit more like what you are seeing on your paper. Okay, now once again, we're going to play around with this a lot, and you're going to become more familiar with it. So if right now it feels a little funny, just hang in there for the ride. So what do I want to say? I want to say that x equals 2 to the y means the same thing. Symbol means can go either direction as y equals log base 2x. And once again, the reason that's the case is because, as I just said, a logarithm is an exponent. So this y is an exponent, and it is a logarithm. This 2 is the base, so it sits in the base position down below to tell you what the base is, and then the only thing remaining is the x, which goes in that position right there. So if b is bigger than 0, if the base is bigger than 0, and the base doesn't equal 1, because anything, a 1 raised to any power is going to be a 1. It won't be a logarithm. It is a fact then that x equals b to the y will always be the same as y equals log whatever that base b is, in that case x. So just a couple sort of comparisons from the last chapter to this new chapter. Exponential function and this new chapter, which is going to be talking about logarithmic functions. Okay, exponential function, we had something like this, f of x equals b to the x, or we would call it y equals b to the x. Over here, f inverse, so this is the inverse of the logarithmic function, is log base bx, or in some cases we might just be referring to it as y, if that's what we're working with. The domain for the exponential function is all reals, and the range for the exponential function is y is bigger than 0. So knowing that inverses, we just switch our x's and y's, and we switch our domain and range. So the domain then for the logarithmic function is x is bigger than 0, and the range for the logarithmic function is all reals, and you can see that on the graph. Okay, back to this word asymptote. In the case of the exponential function, the x-axis is a horizontal asymptote. That means that the function scrapes on down trying to get to the x-axis but never gets there. It's a barrier. So therefore, when we do the inverse, when we reflect over y equals x in the logarithmic function, the y-axis then becomes what we call a vertical asymptote. Same situation. It may look, even on your calculator, as though it's hitting the y-axis, but it really never does because it's what we call an asymptote. Okay, just a couple examples to kind of play around with what I've just shown you here. So, you may get a series of problems that just ask you to write an equation for f inverse x. So let's start with one. Say we are given f of x equals 6 to the x. So what you're going to do is the same process we've done before. You say, well, I realize f of x is just a fancy name for y, so y is equal to 6 to the x. Remember that what we do when we write an inverse is we switch the x and the y, but then we have to solve for y. And even though your brain might want to do some kind of crazy maneuvering to solve for y, you have to, in your head, have a tape that plays that y, or a logarithm, is an exponent. So in this case, since the thing we're solving for is an exponent, I'm going to write y is logarithm, and I look at what the base is, and in this case the base is 6, and then the only thing left to put down is the x. And just to make it clear, it's nice to then actually declare this the inverse by writing that. So f inverse x in this particular case is log base 6x. Okay, let me just give you another one of these. So given, same direction, say you're given f of x equals 1 over 2 to the x. Same steps basically. Change that f of x to a y is equal to 1 over 2 to the x. I'm going to go ahead and I'm going to shift that 2 to the x up so I can think of it in a little different way. So now that would become 2 to the negative x because my exponent is going to change. And if you remember, what this is the same as would be 2 to the negative 1 to the x power, which 2 to the negative 1 is the same as 1/2. So I'm basically just trying to kind of clean up what my base is going to be here. Okay. So now I'm going to go ahead and I'm going to do my inverse. So I'm going to switch my x and my y. So I have x is equal to 1/2 to the y, but now I need to solve for y. Once again, a logarithm is an exponent. Y is in the exponent position, so I'm going to write y equals log. In this case, my base is 1/2, and I put my x right there. Okay, 2 more problems. Solve x equals 12 to the y in terms of x. Now, this is really a very similar question, forcing you to realize that the only way you can solve for y in this case and write it in terms of x is to realize that y is in the exponent position and a logarithm is an exponent. So y is an exponent, so y is a logarithm. I take a look here, I say my base is 12 and my x goes into this position. So basically you notice that you're really just filling 2 positions, this base position and then this position right here. Okay, one last problem. Solve x equals log base 10 y for y in terms of x. So once again, this means we need this thing to say y equals. So a logarithm, so I'm going to say the same thing again, a logarithm is an exponent. So in this particular case, the thing in my exponent position, what logarithm is an exponent then, is my x. In this case, my base is 10. And so when I solve for y, I get y equals 10 to the x. So you'll notice this is going from exponential form to logarithmic form. This one up here, the second one, is going from logarithmic form to exponential form. So you can go back and forth between the 2 different forms. Now your job is to go to mathexcelforschools.com and try the quiz and just see if you can start adjusting to this whole idea of logarithms.